Welcome to Module 3 of Security in a Cloud-Enabled World. This module will be covering security, strategy, governance, and operationalization, which is really all about setting that direction for this new cybersecurity threatened and cloud-enabled world. So in this module, we're going to be focusing on strategy and governance, which are really two parts of the same thing. You really want to make sure that your strategy and governance are considered and thought and planned together. And then operationalization, which is really taking security from a static prevent breach to a dynamic and live assume breach world where you're responding to real world events and attacks and responding to them, recovering from them, remediating them. So we're going to be covering those topics. And we're going to go through context, a little bit about security policy, the continuous threats, continuous innovation that you have to manage as it comes in, the containing risk by assuming breach, and then some summary and takeaways. And what we've really done from the last module to this module is we moved from the Microsoft side of the trustworthy cloud and the security features that are hosted on the Microsoft cloud. And we're now focusing on that roadmap, that element of what elements, what you should be planning for your security in this cloud-enabled world. And it all does start with your data and your identities and protecting them, and of course protecting anything else that you are in control of and that you are operating. So just to set the stage a little bit here, I wanted to give you a quick visual sense of the types of tools that are available to the attackers. And this is kind of an attacker's lens. And as you can see, we've gotten to the point now where the attack tools are literally to the point of right-click attack. And they're cross-platform, and there's a whole lot of maturity and high levels of availability. All the tools that you're seeing here are actually freely available. And actually, I'm sorry, the middle one there is from a hacking team that actually was compromised. These are screenshots of the tools that they were selling to their customers. But the other two are freely available tool, the Metasploit and the Armitage. And this just gives you an idea of how important it is to be doing due diligence. For example, that right-click attack, if you do not patch, as Tim was mentioning in the last couple of modules, if you do not patch, you will get an extra option, or an attacker will get an extra option to use an exploit for whatever you don't patch, because every single available patch is essentially free to the attacker if you do not patch it, because the exploits for a known vulnerability are generally available in the attacker community. So it's very important to do that hygiene to get yourself ahead of the game. And it literally will show up in the right-click attack menu of this tool if you don't patch your system. So that's something to kind of keep in mind on what it looks like to an attacker. And when we look at the strategy, we want to really form this based on an economic perspective. And we want to think about this in terms of the attacker return on investment, or ROI. And ultimately, the way they're looking at this is, what is the benefit of the attack? What do they get out of it, minus the cost of an attack? That is what they're getting. That's their return on the investment. And so we have to look at that benefit of the attack is composed of two things. How many gains do they get per attack? What do they get, how much gains do they get per attack? And how many successful attacks are they able to execute against targets? And then, of course, the cost to acquire access, the cost to get into this environment, and the cost to maintain their presence in the environment so that they can gain on that per attack basis is what their cost of attack is. So when we look at this, we really want to undermine this economic equation so that the attacker gets less and costs more to exploit and to attack your organization. And so the gains per attack and the successful attack, by using detective controls and rapid response processes, you can reduce the benefit that they get because they are not able to stay in as long, and they cannot, or maybe not at all, and you're responding to them and kicking them out much quicker. And then on the cost side, you can increase that attacker cost by running the latest products, keeping them patched, keeping them updated, and applying containment strategies so that when they get in, they get much, much less. And they have to spend more. Perhaps they can't use a well-known vulnerability. Perhaps they have to buy a 0-day to get into your environment because all of your systems are patched. And so you really want to be looking at both sides of that equation as you're building your security strategy. Next, we move on to prioritization. And it's really all about focusing your resources rationally. And you want to avoid, but at the same time, you want to avoid that analysis paralysis. So you want to spend some time thinking about making sure you're investing in the right place, but you don't want to spend all your time planning. You want to get to execution. So you always have to balance those two forces. And on the threat side, you always want to think about and consider the potential impact and the likelihood of a threat actually impacting you. So the potential impact is how much damage could be done. So you worry about the things that would lose control of your entire organization, your entire cloud tenant, all of the data in one of your SaaS services. That is much more important than any given individual account because multiple accounts are just simply worth more, or access to data associated with multiple users is worth more than a single user in most cases. And then the likelihood, of course, is looking at the proven available attacks, like what is easiest for the attacker to do. And so you want to understand how likely is it that they'll be able to use it. Are they going to have to create a custom tool or come up with a 0-day to do it? Or are they going to be able to simply buy something on the black market or use a freely available tool to attack your system? So that's how you think about the threats, is that impact and likelihood. And then on the mitigation side, which is what I spend to mitigate those threats, what actions I take to mitigate those threats, you have to really look at this very pragmatically and say, from a velocity standpoint, can I actually get this deployed? Can I get this out on my network, on my environment quickly? Am I going to be able to be successful with doing that? How much is it going to cost me? So the cost is an important factor. And then, of course, the effectiveness. If I go through all this effort, how much effort will it take for the adversary to get around it? Is it something that they just tweak something and they recompile their code and it's the same code and life is good and they get around your mitigation, such as an antivirus signature? Or is it something that requires a little bit more effort? And so you really have to look at your mitigations and make sure you're investing wisely in that area. Next, as we look at overall security investments, just as a general rule, as opposed to any specific threat and mitigation, our true north is the threats to the mission. So ultimately, your organization has a mission, whether that mission is profitability and shareholder value as a private organization, or whether a government organization has a very specific mission to accomplish. And so that mission, there's generally two different types of assets. One is high-value assets that, to that business, to that organization, these are super valuable, super impactful, that if I lose my proprietary unpatented trade secret, and anybody else can manufacture in the same way I can, or whatever it is that's special about your business, those have a disproportionate impact on your stock price, your value, your ability to accomplish the mission. So you want to make sure you understand those and put a disproportionate amount of investment, security investment, in there. But at the same time, you don't want to completely neglect your broad investments into all assets. So you do want to protect those and excuse me, and protect across all of your workstations, all of your servers. And so you want to look at that and you want to balance those two things, but you don't want to purely put all your money into, and all your security investments rather, and time into just broad assets across the base, but at the same time, you just have to have that balance there. When we look at the threat side of things and how that should be driving our investments, the previous attacks we've actually seen on our organization is the #1 indicator. Because when I think about an attacker at a workbench, the first thing they're going to use is the tool that they just used, because it's in reach, it's available, and they know it's worked in the past, or they've attempted it in the past. The next thing that you want to look at after that is what else is being used against your peers in your industry. And this is where ISACs, or Intelligence Sharing and Analysis Centers, ISACs, come in handy if your industry does have one. Some industries have them, some don't. They're in various stages of maturity. But what's happening in your industry is most likely the next thing that an attacker would use against you, because if they're targeting your industry with a specific technique or piece of malware, they're probably interested in that same set of data across the industry. So that's the next most likely thing. And then broad trends and threats. So if something's being used across multiple industries, it's very likely your industry will also be impacted as well. So these are the things that you worry about the most on the threat side as far as what an attacker may be doing and may be using against you and what kind of data they may be targeting. And then last, not something we want to ignore, but something that we want to prioritize last is theoretical attacks. Most adversaries don't have to or want to spend money to create new tools and new attack techniques. They don't need to do that research in most cases, and so they're not going to. So the theoretical attacks, they're there and they're possible, but you always want to be very careful that you're not spending money on mitigating a theoretical attack and you're missing the realistic proven attacks that are already in use. So it's really about balancing how you spend your money on and your time and your resources on the mission and protecting that, as well as looking at the threats from that balanced view and the likelihood that they're going to use that against you. So the next thing we're going to do here is we're actually going to borrow a concept from the medical world. And this concept dates back to the early days of the ancient Greeks. I don't know if it's the early days of the ancient Greeks, but it's the ancient Greeks nonetheless. And the principle is first do no harm. And so as we look strategically about an organization going to the cloud and adopting cloud technology, the first thing that we want to do, given that we have so much security risk that we have to mitigate and so much to prioritize, what is the first thing that we have to worry about? Well, we have a certain set of risk we're already accepting, whether it's explicit or implicitly accepting for our on-premises assets now. As we migrate those assets to the cloud, we want to make sure that we are mitigating the net new risks. So we want to make sure we're not making the security worse than it is. So we're mitigating the net new risks and any increased risks. So we'll talk a little bit about what that looks like here. So with this do no harm lens, when we look at moving a workload to the cloud, really any cloud service, the one thing that's typically in most organizations different is that the admin interface is the ability for the administrator to authenticate with a legit set of credentials, or an attacker to authenticate with a legit set of credentials, or to attempt authentication from the public internet. Generally in most organizations, most enterprises, the administrative interfaces for your virtualization console, your management tools, your Active Directory, you have to be on the corporate network to be able to access those. In the cloud world, those are exposed to the public internet. So that's a net new risk that generally doesn't exist on most on-prem enterprises today. And so that's one of the first mitigations that should be focused on as part of your going to the cloud plan. And you want to make sure you include that in your project to mitigate that particular risk as you go to the cloud. So that's risk one. Risk two is if you are doing IaaS or PaaS, so infrastructure as a service or platform as a service, and you're managing VMs, and in the case of IaaS, you're managing the full VM. In the case of PaaS, you're managing a small part of the VM, but you do manage the network connections and connectivity between the VMs, whether they're web roles or worker roles or what have you. And because the cloud services can handle both intranet or production type networks as well as extranet, internet exposed networks, you don't want to expose yourself to risk by inadvertently connecting a resource that shouldn't be on the direct internet to the internet. And so you want to avoid that mistake, and that's something in the IaaS and PaaS world that you do need to mitigate, and that's just through careful network design, making a good design and then implementing it correctly. And then the third risk is that in some cases, and this is only some organizations, if you have access to corporate email and applications that requires VPN, that requires corporate network access, and you don't have Outlook Web Access or OWA or other services available to the internet for mobile phones and the like, if you force those to VPN in that case, moving to the cloud will put availability of user interfaces to the public internet, and so that risk needs to be mitigated or accepted. But those are the primary risks that we typically see enterprise organizations face. And the big one that we focus on is risk one there, about those admin interfaces on the internet. So when we look at mitigating that, and we'll address this mostly in the administrative control section, we really look for hardened administrative workstations. We look for logon restrictions to make sure that those admin accounts can't be used on any privately owned or home computer or the like. Strong or multi-factor authentication to protect those accounts, and administrative models, standards, and practices to make sure that the administrators, the privileges are only given to authorized accounts, that they're following standards, that you're not, for example, leaving the project manager for an Azure or Office 365 onboarding or something like that. We're not leaving their Hotmail or their live.com address on there as a tenant admin. That we actually are following and enforcing those standards and practices and following an administrative model that's documented. And administrator education as well, and making sure the administrators are aware of where to use those credentials, where not to use those, to follow those standards. So those are the really key factors to protect that administrative control. And of course, because we're talking about live security against live adversaries, administrative logging and alerting, and the response and recovery processes to follow up on that. If you do have an alert, make sure you're able to triage it, investigate it, and then remediate any issues with it. So the next piece is around security policy. And security policy is not one of those super attractive things for most technical folks. But security policy has a very, very important function, which is it takes the intention that's in your head and it creates a bridge between that intention and action. It captures the intent of the organization in such a way that people can take action against that and they can do the right actions. And so that's a really key factor, because without that, it's very difficult for anyone to know what they should or shouldn't be doing without a written policy from the organization that says we only adopt cloud services that are monitored by IT. We only adopt cloud services that meet a certain security standard in terms of they follow a security development lifecycle process. These kinds of things have to be written down if you expect your organization to follow them. So having that policy captured and written down really helps give your organization that North Star, that compass heading, so that they can do the right thing. So when we look at a good policy regime, obviously the first criteria is that it's written down. And another thing that we see that's a huge success factor is that usability and security have to be balanced. If you try to prevent someone from doing something and it makes it difficult for them to do their job, we find frequently that they will find a way around it. And most people are very resourceful at finding a way to get their job done and get it done efficiently. So if you don't consider that usability and don't consider those business productivity requirements in the security requirements, then what you're going to end up with is a failed security requirement. So it's very critical to balance that security and usability in the design process. Security policies, keeping them up to date, is absolutely critical, because regulatory and compliance stuff can change, but more importantly, evolving threats, new cloud capabilities, and organizational objectives may change as well. So you want to make sure you're keeping an eye on those and keeping those up to date as new things come online. And then this last piece about embracing shadow IT. This is a little bit controversial for some security folks, but the reality is that if shadow IT exists, and shadow IT here is referring to when the business users or other users in the organization leverage services, capabilities, and technology that is not sanctioned or managed by IT. And so this shadow IT represents an area where where effectively the business has decided that IT is not able to meet their needs, and they've gone off and met their needs in their own way. And this is something that, quite frankly, is an opportunity for IT and IT security, because shadow IT represents a place that IT needs to be and needs to be helping the business. And ultimately, IT and IT security, especially IT security, they are going to be responsible and accountable for the risk that is assumed by the organization. So if they're not aware of it, then it's a risk that IT security is not managing. And so that doesn't mean that the IT should necessarily crack down, or IT security should necessarily crack down on that and prevent those things from happening. It doesn't mean that they should necessarily allow it. It means that it's an opportunity where they can engage with the business, find out what drove the requirement, and then find a way to do both a usable and secure way of meeting that business's needs. And so it's really an opportunity to build that partnership and to work with them. So we believe very strongly that shadow IT is an opportunity to really help mitigate risk to the organization, as well as meeting those business capabilities and needs of the organization. So the next piece is about managing continuous threats, and this is where security becomes an operational discipline, not just a static prevention and static set of controls. And so what this really is composed of is a set of operational capabilities that allow you to monitor alerts. These are things that should never happen, or should be investigated if they do happen. The ability to investigate incidents, so this is security operational responsibilities, and then initiating remediation actions to clean them up, and of course integrating lessons learned after actions. And so this is also where building external context comes in, of understanding threats and how they apply to you. ISAC, Information Sharing and Analysis Centers, would feed into here, other threat intelligence feeds and the like. And of course, if you have the means to have an authorized red team or a penetration test on your infrastructure, on your environment, on your applications, those are great ways to test it and validate that you are in fact defending against realistic threats, as opposed to simply theoretical threats. So when we pull this all together and take a look at how the detective controls and security operations interact, detective controls have alerts and logs. Alerts are things that happen live, and they're very heavily filtered, so that they should be very low on the false positive rate, so that if you get an alert, it's generally worth investigating. You don't want to have thousands of alerts that you can't investigate, because that creates a set of liability, but doesn't give you any value for them. So you want to make sure your alerts are as valuable as possible, and you don't have too many alerts just for the sake of volume. And then logs are really about enabling an investigation. We'll see how that works in a moment. And then the response and framework and process is something, all of these blue boxes here are things that you can set up ahead of time. And so the response framework and the processes and who to notify and what to do, and what are the stages of your investigation, what are the stages of resolution, all of those pieces are part of your response framework and processes. And then separate from that are a set of remediation procedures. So in case of a compromised account, in case of a compromised computer, these are the specific things we do. And some of those may include, call a incident response and recovery company. For example, Microsoft has an incident response and investigation and recovery teams that assist our customers. There are a number of other organizations in the industry as well. But setting all those up ahead of time so that you know what to do if a particular thing happens. So all those blue boxes are items you can set up ahead of time. And then what happens is the alerts provide a signal. So the alert says, hey, we got something that needs to be investigated. So the investigation happens. It typically leverages the logs. It can be very iterative in nature as the operations folks figure out what's going on. And then if an attack is confirmed, kick off a recovery operation so that And there is the possibility here that you may decide to let an adversary run around your network for a little while and monitor them to understand what their intention is. If it's more valuable for you to get that intelligence, you may want to do that. But in most cases, most organizations will initiate a recovery operation to go ahead and eject that adversary from the network. So that recovery operation kicks off, and in the process, we'll utilize those remediation procedures, one or more of them as appropriate. And then after the recovery is completed, close the recovery operation and then integrate those lessons learned, which is a very key factor in these types of security operations. So next step is to manage continuous innovation. And this is a recognition that in the cloud world, things release very quickly. Features are coming up on a monthly, sometimes a weekly, sometimes more frequently basis, updates to capabilities, and if your organization is subscribed to multiple cloud services, there's a whole lot of potential sources that would even increase the frequency in aggregate. And so managing this is a very key thing to deal with in the cloud world. And you can define a cadence that makes sense for you. We suggest a monthly cadence to make sure you're looking at what's happening in the cloud now, what's being released, what's being projected for the next month or two, and providing security assessments, operational integration assessments, and really making sure you have that constant process to understand what's coming and how to manage that and how your organization is going to deploy, disable, configure, enable, or just generally use those features. And then at the same time, you also want to keep on top of configuration drift. So periodic reviews to make sure that everything is still configured as it's intended is also super important to make sure that your intention is still being captured. So the next piece is really talking about containment strategies based on the assumption of breach. So we've talked about the assumed breach and how critical it is to assume breach so you can defend the important assets in your network from the other assets and just assets in general from other assets if compromised. And the Titanic here provides a great visual example of how important it is to make sure that your containment strategies are complete, that the bulkheads go all the way up, as it were. And really gives us a good visual illustration. And so when we look at assumed breach, we have to operationalize security so that we're containing it in terms of the time an adversary has on the network, and that's a combination of detective controls and those response and recovery processes. And then the second piece is you really want to identify and understand what your high-value assets are, which we'll talk a little bit more in the information protection module, and defend those against those internal or external attacks. And then we're going to talk about a little bit more in this section is using security zones to compartmentalize the assets and contain the attacks so that an adversary getting access to any given security zone will have a difficult time with getting into the other ones. And there's a couple key differences from the traditional approaches that we're going to be discussing here on how to approach this differently. So when we look at containment and segmentation today, we're actually doing this in a lot of ways. Most organizations have an intranet or production network. Most organizations have a DMZ or extranet network, and they generally have a firewall to prevent arbitrary access between them. Some organizations have a legacy network or a physical control or PCN or SCADA network, and so organizations are doing this today. But the reality is there's a lot of challenges and limitations of the way it's being done today, because the networking is that first line of defense. You do want to block it at the network level. But ultimately, looking at purely at a network level is not enough, because the attackers, as well as many software products, are really adept at going through different ports, different protocols, and bypassing firewalls as needed to enable business and technology capabilities. And so what we see is those purely network-centric implementations that are port and protocol only based, they're easily evaded by the attackers. these IP as an identity really doesn't scale to the cloud and global level. And then within a forest, we see some organizations trying to, within a forest or an environment or what we call a security zone, they're creating issues that by trying to apply firewalls there when they simply don't work from a purely operational standpoint. We'll talk about how we're recommending to do things differently. And so the network-centric approach really relies on a couple of very weak assumptions, which is that an IP address is a host identity, which only really works in a static IP world, and it only works if an adversary does not have the ability to spoof an IP, and an adversary does have that ability. It has this weak assumption that a TCP or UDP port is an application identity, and that's also a very weak assumption that is frequently proven wrong, where most protocols tunnel over 443 or TLS, for example. And the challenge is, if you go through and you open up this and you have these various different layers, but you're using either the same identity or a set of data that goes across these ports or an application that connects over a port that's been specified, such as 443 or 80, that the networking folks didn't anticipate using. Any one of those layers can create a bridge across these security zones. So having that pure networking approach is something that creates a lot of risk, and it's something that can be worked around. Another assumption that, as we look at the slides here, another assumption that is very interested is networks are frequently considered trusted, and they're called a trusted network. Well, the interesting thing about the trustworthiness of a network is it really can't exceed the trustworthiness of the least trustworthy node. So if you have one compromised or malicious computer on there, or one weakly configured computer, or you have a public network jack in the lobby of your organization, that network is only as trustworthy as that least trustworthy node. And so we have to be very careful about applying trust to a network on a pure network basis. And so when we take a look at how, so that's sort of the between zones challenges. Now we switch over to the within a zone challenge. And what we see typically when someone tries to use a firewall within, say, a production environment for an Active Directory forest, or between sites, or overly aggressive sometimes within a DMZ. But everyone starts with the default deny, which is very good security practice. Let's default deny, and we only allow exceptions. A very good whitelisting approach. The second stage is that there's a whole lot of pain and cost within a production zone when you try to do this, because clients need to communicate to DCs quite frequently. They need to communicate to servers quite frequently. Domain controllers need to communicate with each other frequently. There's a high volume and a high frequency of traffic between these. And with the security guys trying to keep it to as few ports and protocols as possible, the operations guys trying to keep the thing going, you get this massive amount of friction. You get a productivity decline, which is a business cost. You get a loss of confidence IT or IT security, and in a sense, the creation of shadow IT, which creates organizational risk, which is because that shadow IT is probably going to be less secure than anything that you could put up. And then at the end result, unfortunately, is by the time all this is done, pretty much everyone gives up, and it goes to a default allow state or a nearly default allow state. So that's the story we typically see play out when someone tries to set up firewalls within a zone, and that's why we do recommend against that particular approach. So the way that we're approaching this today is we map a term we're calling security zones to what would be a normal typical environment, a production DMZ, a legacy environment, a PCN SCADA, high-value asset environment, and the like. We'll show those in a moment. And we generally start with that same isolation approach with the primary defense is the network controls with approved exceptions. Now, what we're doing differently is we need to add rigor to the isolation exceptions. We don't want to just say, okay, port 443, port 80, port 21, port 25, we're going to allow those. We don't want to be doing that. We want to add rigor to it and perform a threat model exercise, which we'll cover in the application section on how to do that. That really considers all layers of an exception, the identity application data, the authentication, encryption, and the like. We want to make sure that we have that good full coverage on it and that we're actually understanding what's crossing those major trust boundaries. And then within a security zone, we don't want to focus on firewalls because it's non-productive. We want to focus the integrity of the admin model to make sure that an admin's credentials can't be stolen, to make sure that administrative privileges can't be abused, that too many administrative privileges aren't given out, or too many privileges to interesting resources or valuable resources are given out. We want to look at the administrative control and make that the priority for containing risk within a zone, as opposed to using internal firewalls, which is essentially, in many cases, destined to fail. So when we look at security zones in a typical organization, they generally separate vastly different value or trust levels or exposure to risk. And they tend to be fairly expensive, so you want to minimize to just the number needed, and you want to defend them vigorously. So a production versus extranet is typical organization would have. A legacy isolation zone, if you have, say, some Windows 2003 computers that you're not able to apply security updates to anymore because they're not available, and you have applications that maybe they run a physical machine, or they run some application that you cannot shut down at this particular point in time. You can have a legacy isolation zone. If you have a separate fabric that is running a private cloud fabric, that may justify an additional zone. Regulated data such as personally identifiable information, personal health information, high-value assets that are very specific high-value assets that are known to the organization, or process control or SCADA. So those are the typical scenarios that we see where a security zone would be justified. And when we look at that administrative control, we have a tier model. We actually published this in the Pass the Hash white paper version 2, available at www.microsoft.com/PTH. That's PTH as in Pass the Hash, Papa Tango Hotel. And this tier model really separates the administrative levels on it to contain the risk, so that the administrator of a given device or workstation or any individual user device does not have the ability to escalate to become, through credential theft or other means, an administrator of servers and enterprise applications, and then neither of those have the ability to escalate through attacker tools and the like to become a domain or enterprise admin that has access to the entire password database. And so this tier model of the tier 0 in control of all identities and effectively all assets in the environment, tier 1 being your enterprise assets, and tier 2 being your individual user or individual device assets. Establishing those protections against those elevations of privilege is much, much more important within a zone than attempting to do firewall rules, because within a zone there has to be that trust, that intercommunication. So when we take a look at how we apply it on these, focusing on that security zone has to focus on that administrative integrity, and it has to enable those daily operations. And so there's the set of recommendations in that white paper I just mentioned that talk about how to apply those, and then you can apply these different tiering models. You may or may not have workstations in every zone. You may have fewer workstations or servers, depending, but ultimately this is really about making sure that administrative integrity is high within each of the zones. So, in summary, the strategy and the policy really needs to be written down, has to be clear, it has to be up to date, it has to be usable. Start with do no harm. So if you're already on the cloud, or if your deadlines are short and you have to get on the cloud soon, start with that do no harm. Start with mitigating the administrative control. If you're doing IaaS or PaaS, make sure you're got protections in place to make sure that intranet resources do not become internet resources inadvertently. And then just get used to some of the new normal elements of the business, that you have security operations, whether it's run in-house with your own full-time employees that are operating it, whether it's contracted out, or whether it's a service that you subscribe to. But having someone that's there to respond to those alerts and look at those alerts is critical, because it contains the amount of time an adversary can operate within your network. Have those monthly meetings to keep up with the technology and the releases and the capabilities. And then, focusing that security on those usability and business goals, so you're balancing that at all times. And of course, build that containment strategy to help deal with the assumption of breach. And so that's Module 3, the security, governance, strategy, and operationalization. And we'll see you in Module 4.